Okay, YouTube, in this video we're going to look at solving some rational equations using our least common denominator method again. But we're going to look to make sure that we check for what we call extraneous solutions. And so basically the note that I want to mention here is that when we multiply everything in this equation by its LCD and completely wipe out the denominators, we sometimes introduce a higher degree polynomial into the equation, which means that you'll get solutions that work out algebraically, some extra ones. But when you plug them back into this original equation, they actually tend not to work. And so let's go ahead and do this. Let's solve this equation here using our LCD method, which means first and foremost, we need to find the least common denominator. So the least common denominator, of course, this requires us to factor all of our denominators. And the first thing I notice is that this, on the right-hand side, this first rational expression is a difference of squares. So we have an x plus 3, x minus 3, and then over here on the right side also we have a 4x over an x plus 3. So in terms of finding the least common denominator, it is the least common multiple of all of our denominators. And remember that to find your least common multiple, we'll list the highest power of every factor that occurs in any of these denominators. So the highest power of x minus 3 that occurs in any of these denominators is x minus 3 to the first. So we're going to put x minus 3 on our list here, x minus 3 to the first. And then I notice that x plus 3 at most occurs one time in every denominator. And so now that we have our least common multiple here, which is the least common denominator, we're going to take both sides of this equation times the LCD. So without having to rewrite it all, what I'm going to do is just drop brackets around this. And we'll go ahead and multiply by our x minus 3, x plus 3 here on both sides. I'm going to squeeze this in over here. X, better keep it consistent, x minus 3, x plus 3. And so on the left side, the x minus 3's cancel out. We get left with 6 times the x plus 3. And on the right side here, as we distribute, we're going to see that our x minus 3 and x plus 3 cancel out with this quantity, and we get left with really 8x squared there. So 8x squared minus now, and over here our x plus 3's cancel out, leaving behind the 4x that was on top to be multiplied by the remaining x minus 3 factor. So let's go ahead and do our thing. Let's go ahead and simplify both sides here by distributing. So we get 6x plus 18 on the left side. On the right side we get 8x squared. I suppose this would be minus 4x squared after we distribute here, plus, okay, a negative 4x times a positive, or a negative 3 is a positive 12x here. And then follow this up by, I guess, simplifying these even further. I'm going to rewrite this up here. We have 6x plus 18 on the left-hand side. And on the right-hand side, it looks like we would have a total of 4x's squared, and this is plus 12x. So as we typically do when we have equations involving x's squared and x's to the first, or any variety thereof, we set it equal to 0 when we solve by factoring. So let's go ahead and do this. We're going to set this equal to 0, both sides equal to 0, by subtracting, let me put it over here then, 6x's and 18 constants. And we get 0, we'll say on the left-hand side. On the right side we get 4x squared. This would be plus 6x here, plus 6x, minus 18. So the first thing I notice as I'm going to factor is a greatest common factor of 2. And so what we could do is we could factor that out, kind of reducing our values here, minus 9. And we could divide even everything here by 2 and see if we can't get something to factor for us. And so we get 0 and 2x squared plus 3x minus 9. So in terms of factoring this, let's go ahead and do a little bit of guess and check. One thing we know, in order to get a 2x squared up front, we'd have to have a 2x and x in the front. And in order to get a negative 9 in the back, either it's going to be a positive 3 and a negative 3, okay, or it's going to be a positive 9 and a negative 1, or a negative 9 and a positive 1. I'm going to start by saying, what if we had a positive 3, negative 3? Well, now we've guaranteed the first term. We've guaranteed the last term. The question is, do we get this middle term? So we check our outer and our inner here. Looks like if you take 2x times a negative 3, we get a negative 6x. And if you take 3 times x, we get a positive 3x. These two terms would add up to be a negative 3x, which is not what we have in the middle. But that's not to say we can't just go ahead and do this. We'll switch our signs around, which would essentially, when we multiply our outer and our inner again here, switch the signs on these, and so we would get a positive 3x. So these are our two factors here. What I'd like to do is go ahead and set them equal to 0 and solve them. So if 2x minus 3 is 0, we get x is equal to, add the 3 divided by 2, we get 3 halves here. And if x plus 3 is equal to 0, okay, then certainly x would have to be equal to negative 3. So again, our goal here was to make sure that each of these solutions works. Well, let's plug them back into the original equation to check to see that they do work. And of both of these solutions right here, one that I want to check first is the negative 3, just because it's the whole number value. So I'm going to do my work up here, and what we're doing is we're replacing all instances of our x variable here with a negative 3. So we get a negative 3 here. our original expression had an 8x squared, okay, over x squared minus 9 minus 4 times x all over x plus 3. So if we replace all of these with a negative 3 and we inspect this situation here, it looks like on the left side we would get negative 3 minus 3 is negative 6, so we get 6 over negative 6. On the right side, 3 squared here, or negative 3 squared, would be 9, so 8 times 9 we get a 72. On the bottom we get 9 minus 9, so 0. Hope you see the problem with that. And we say a negative 12 up here, and down here we get a 0 as well. So the fact that we got zeros in the denominator would be a bad thing. So way we checked this was to plug it back into the original equation. One thing that I want to point out is, again, as you deal with more and more rational expressions, a good thing to do right off the bat would have been to start by finding your restricted values. And what we could see here is that because our denominators, their factors are x minus 3 and x plus 3, then zeros of x minus 3 and x plus 3 are plus or minus 3. So we wouldn't want to use those because it would cause our denominator values to collapse to 0. And without having to plug it back into our original equation, we could have seen that this right here, this must be a restricted x value. So we would lose this off the solutions, and 3/2 would most likely work for us here. And I'm not going to plug that back in just because I feel like I'd waste a lot of your time working with fractions when you could see that it works in the equation on your own. I'd let you do that. So with 7 and 8 here, let me go ahead and give you a hint. What I want you to do is go ahead and start by factoring these differences of squares and then finding your least common multiple of all your denominators. But once you multiply both sides by the LCD, go ahead and solve that resulting equation and finish up by checking both your solutions against your restricted values here. Cheers.